Hi everyone, in today's lesson you will learn what an alternate angle is. By the end of this lesson you should be able to find unknown angles using alternate angles. Okay, so just the same as corresponding angles, we're going to start by drawing a line through two parallel lines. We can see that this forms a Z shape, like so. Now this angle here and this angle here are said to alternate, and this means that they are equal, okay? So the angle that's tucked in one bit of the Z shape is equal to the angle that's tucked into the other bit. There is more than one Z shape formed when drawing a line through two parallel lines, so watch out because some of them might be backwards as well. We can see this is another shot of Z shape being formed, which means that this angle is also alternate to this angle, okay? So mark the angles which are alternate to the ones already drawn. Okay, so we can see there's a clear Z shape in the first one, which means that this angle here must also be the same as this angle here. In part B, let's find the Z shape. So if we go down here, we can see that the Z shape's here, and that means that this angle is alternate to the angle they've given us. Use three letters to name the pair of alternate angles. So this is one of the angles here. This angle is angle MDR. This angle here is another one of the angles. This is angle ZRD. In part B, our Z shape is here, which means it's this angle and this angle that are alternate. So our first angle is angle SXC and our second angle is angle XCP. Write down the values of the angles marked with a letter. So this angle here is alternate to this angle here, which means we can just state that angle A is 25 degrees. If I pick out the Z shape from this second shape, I know that this angle here is alternate to this angle here, which means angle E is 82 degrees. Now let's try and fill in all of the missing angles. So let me start by finding my Z shape. So I can see that there is a Z shape formed here, which means that this angle here is alternate to this angle here, which means that this angle here is 43 degrees. Okay, what else do I know? Well, I know that if this is a right angle here, this also must be a right angle because 90 plus 90 gives us a straight line of 180. So I'm going to do 90, take away 43, which gives me 47, and fill that in here. Now I can see there is a triangle shape here. I'm going to add together what I've been given within that triangle and take it away from 180 because remember there's 180 degrees in a triangle. 43 plus 47 is 90. 180 minus 90 gives me 90. So up here is a right angle of 90 degrees. Since this is a straight line and one side is a right angle, the other side must also be a right angle, so it adds up to 180. And that is us finished. We've filled in every missing angle. In this example, let's start by using X angles, so vertically opposite angles. I can see there is an X shape formed here, which tells me that this angle here must be 42 degrees. Using a straight line here, I can do 180 minus 42, which gives me 138 degrees, which tells me it must be 138 degrees in here and in here. Using Z angles, I can see a Z shape is formed here. So I know that 42 must also be in here. And using another Z shape formed here, I know that 138 must also be in here. Using x angles, I know that this angle here must be 138 and that this angle here must be 42. I know that because this is a straight line and one side of it is 90 degrees, the other side must also be 90 degrees. Using x angles or straight lines, I can say that every angle here must be 90 degrees. I've got a little triangle down the bottom, so I'm going to add my 90 with 42 to get me 132 and subtract that away from 180 to get me 48 degrees. So this angle here must be 48 degrees. Now I can either use Z angles or F angles up here to say that we also have right angles forming up here in the top left. Every angle is now filled out within this, so that is us finished.